So we talked a little bit about this last time. I believe at this point in the year, A, B, and BC are still they're sort of in the same place ish, and so I get confused sometimes about which class has done what. But um, this is functions that are defined by an integral, and this is just I wanted to show you another AP example. Yeah. Um, so this is right off of an AP exam. Need to do that so that I can see the whole thing. So the graph of the function f consisting of 3 line segments and a quarter of a circle is shown above. Let g be the function given by g of x is the integral from 1 to x of f of t dt. So this is a little bit easier than the one that we did where there was like a 2x minus the integral, where it made it a little more difficult. Find the average rate of change of g from x equals negative 5 to x equals 5. All right, so the average rate of change of g is going to be g of 5 minus g of negative 5 over 5 minus negative 5. All right, so g of 5 is going to be the integral from 1 to 5. So from here to 2, 3, 4, 5 to here. So let's see, 4, 6, 8, and this is going to be 4, so that's going to be 12. Yes?
Yes.
And you do want to show that, right? Part of, what is expected on these is that you're communicating. Yes, you could probably find the other one and subtract it in your head, but you want to show those things. And then the integral from 1 to negative 5. Now that's quite a bit more difficult, but if we're doing the integral from 1 to negative 5 of f of t dt, which is g of negative 5, how can I make that a little simpler? Yeah, flipping this and doing the opposite. So this is going to be the opposite of the integral from negative 5 to 1 of f of t dt. Then all of f is below the x-axis, except for the couple of places where it touches it on that interval. So that's going to give me a negative answer, but I'm taking the opposite of that. So I'm going to get a positive. So I just need to count up the area that's enclosed in these pieces. So let's see, that's base of 3, height of 4. So that has an area of 6. This is half of a circle with a radius of 2. So that has an area of pi. And this has an area of 1. So it's 7 plus pi. All over 10. By the way, this is a free response question on an AP exam. So how much simplifying should I do? None. All right, let's check to make sure that we have that right. 12 minus pi plus 7 over 10. Okay, cool. Next, find the instantaneous rate of change of g with respect to x at x equals 3, or state that it doesn't exist. Okay. Well, what is g prime of x going to be equal to?
F of t, yeah, or f of x.
Yeah, f of x. So the instantaneous rate of change of g at x equals 3 is f at 3, which is 4, right? So again, I'm writing all that out to show them my thought process, especially in case I make some mistake along the way. Okay, you don't want to write too much, but I find that for most students, you need to write more than you think you need. You don't want to get into situations where I've graded ones where this person has written a novel. And frequently when that happens, not all the time, but frequently that happens, they're trying everything possible to get something that might be right. Okay, they're just slinging mud at the wall and seeing what sticks. Okay, the problem with that is if anywhere in that they say something that's untrue, it's game over. And that's what almost always happens when someone does that. They say all these things, and frequently they say things that are just not true. And so then they can't get any credit, even if they do say something that is true and is germane to what we're doing. All right. On what open intervals, if any, is the graph of g concave up? All right. So what does concave up mean?
First derivative is increasing.
Yeah. G concave up means that g prime is increasing. And what is g prime of x equal to? F of x. So where is f of x increasing? All right, well, that's from -5 to -2. And then from 0 to 3?
Yes.
Thank you. So you'll notice on this, they're checking whether you know the definitions of these things. They're checking in part B, do you know the first part of the fundamental theorem? Here, they're checking, do you know what the definition of concave up is? They're not going to ask you to write, what is the second fundamental or the fundamental theorem or what is the definition of concave up. But they're testing whether you know it by seeing, can you use it properly? All right, last part. Find all x values on the interval from -5 to 5 at which g has a critical point. Classify each critical point as the location of a local minimum, a local maximum, or neither, and justify your answers. Okay, so g of x has a critical point where? And I'm talking in general. What is the definition of a critical point?
0 undefined.
Where what's 0 or undefined?
The derivative.
Yeah,
First derivative.
where g prime of x, which as we've said multiple times now, equals f of x, equals 0 or is undefined. Well, f of x is defined everywhere in between -5 and 5, but it's 0 at x is -2 and at x is equal to 1. All right. at x is negative 2, remember this is the graph of the derivative, will we have a local minimum, local maximum, or neither? Neither. Because
It's not 0. The
what's not 0?
f of x.
F of x is 0 at
Oh.
negative 2.
Because it's not differentiable.
Nope.
I,
Okay, so
because
go ahead.
it's a quantity. Never mind.
Okay, so let's review. Okay, so how do you know when a function is increasing?
The derivative is increasing?
No.
No, the function is increasing.
How do I know when a function is increasing?
The
Derivative is positive.
The derivative is positive. How do I know when a function is decreasing?
Derivative is negative.
The derivative is negative. So my derivative at this point went from negative to negative again.
Oh.
So my function must have gone from decreasing, had some sort of little flat spot, and then be decreasing again. So at x equals negative 2, g has neither, because g prime of x does not change sign. What about at x equals 1?
A minimum.
Yeah, we're going to have a minimum because
The derivative changes from negative to positive.
exactly right. So at x equals 1, g has a local minimum because g prime of x changes from negative to positive. And if you want to go on from there, that is sufficient. But you could also say, thus, g changes from decreasing to increasing. You don't have to say that last part. I think it's a good idea to. You're making it really clear that you know what you're talking about. All right, let's see. Has neither because g prime does not change sign. G has a local minimum because g prime changes from negative to positive. I think we have, oh, I skipped part. Did you see it?
Justify.
Justify your answer. And I'll say because I've sort of said it. G prime is increasing on these intervals. Yeah. By the way, I said it 3 different times that g prime is equal to f of x. Technically speaking, you don't have to say it every time. Once you've said it once in one part, you don't have to restate it in the other ones. I do because I think it's a good habit, but it's not a requirement. Okay? Once you've stated it, it's like this is true for the whole problem. All right. Well, that's all I have for you today.